If I had any champagne, I'd pop the cork and I'd celebrate. Because right now is the end, well, not the end, but anyways, a project that I thought about well over a year ago, and one I tried to do last year, but my 2 attempts at it kind of failed miserably. This one hasn't worked out too bad, although it worked out much better than I expected. The last few videos have been about me rewiring a Bionx Smart-E motor to be able to run with an external controller. And we actually have succeeded in 2 different projects that I have been wanting to do for a long time. I have a strong GTS 210 sold by Canadian Tire and discontinued in 2008, pretty much because they had too many returns, too many problems. The original motor size was supposed to be a 150 millimeter dropout, but by the time it was all said and done, it was all bolted up. It was actually closer to about 160. Now here is the original rear end and the original motor right here. So as you can see, it's a fair size. It's fairly thick. It's a good size motor. Now, with the tape measure out, you can see roughly that it measures right in about, whoops, there we go. It measures in right about 165. Yeah, I would say about 165 this one. They were all a little bit different anyways, but I would say about 165 for this one. Now, what we've done is we've replaced the brushed motor. This is a brushed geared motor. That was a piece of crap. It was a copy of a White motor, I believe was the guy's name who made them. Anyways, they're supposed to be a really good motor. They even have the little N on the side here, or a little symbol that was supposed to be for his motors or whatever the heck it was. Anyway, the main point of this being is that the Bionx motor, the Smart-E, is now mounted in the strong bike and lined up fairly straight. It's not 100% perfect, but then again, none of these bikes were ever made 100% perfect. They were welded in China. They are a solid steel frame. This is a 135 millimeter dropout, but because of the axle length, what I've actually done is I put in some spacers on this side. I used, believe it or not, a couple of pieces of wood and my back steps to bend the rear frame portion down to what I need, including straightening out the back portion of the arms, the dropouts, where the dropouts are, to be able to line those up nice and straight so they didn't sit kind of crooked. But anyways, as you can see, I have a temporary rig up over here. I haven't got the chain in. And yes, by the way, if you're doing phase testing, you're testing your phase wires and motor direction and all that, don't leave your chain on, because sometimes if you reverse direction accidentally, your pedals can go flying and tear things up a little bit. Luckily, my kickstand stopped it, and but anyways, I got wedged on my kickstand and scratched up my pedal. I don't like that. Anyway, I've got the 2 controllers mounted on the bike right now because I was running with a Lion sensorless controller mounted in the original control box, running a front Crystal Light HS3522 motor. Now I also have the Cycle Analyst attached here, and I haven't got it plugged in for this test yet, just to be certain, because that adds extra features to the controller. Now, again, I mean, I don't even have Anderson power pole on my phase wires, and as you can see, my my hall wires here are just kind of jury-rigged to be able to quickly switch them around and check out the correct phases. So it is a controller from ebikes.ca, a Grin Technologies. Here, I'll turn the camera, and hopefully that'll pick up the specs and it won't be too close, and you can actually read that there a bit. But basically it is a 20 amp controller. It is a sensored controller, and it has forward and reverse, as well as the electronic brake and regeneration, and the direct plug-in for cycle analyst. It's a nice little unit, has an off-on switch. And anyways, on with the test. So, the controller is on. The throttle is unfortunately way over here, but here is the Bionx Smart-E motor with an external controller and a 48 volt 15 amp hour lithium magnesium battery pack. And we'll hit the electric brake, or electronic braking, regeneration, whatever you want to call it. We've activated it. So as you can see, it runs very nicely. Yes, the wheel's a little bit out of round. I haven't taken it to the shop to have it trued up because I just roughly laced it up there yesterday myself. So it does wobble a bit. That's not the motor wobbling, that's just the tire that wobbles a little bit. And now this is flat out full throttle from a standing start, just so you can see the amount of power or torque this thing has, because it's moving my whole stand, and my stand is fairly heavy duty. It's nothing major, but it's still heavy duty enough. I mean, as you can hear, it leaves the freewheel behind by quite a bit, so it's quite torquey. It's got a fair bit of power. I can't wait to get this thing off the stand and road test it. I'm very happy with the results there. Nice, smooth. Doesn't feel too warm. I don't feel any heat in my phase wires at all. Now, granted, that's no load, but, you know, I had to use 18 gauge wires because, well, that was all I had here when I was soldering it up and I was putting it together. And that was about all I could fit through the housing because I didn't want to groove out the axle. But if I ever have to take it apart again, I think I'll groove out the axle and put some nice 12 gauge wires into there as far as that goes. So, anyways, 2 projects in one, completed almost at once. I still have to tidy everything up and lace everything off and put the chain back on. But it looks like the Lion controller is coming out and the Crystalite motor is coming off the front, and we're going to have a much lighter bike that's running with a rear drive, which I wanted because I'm not really crazy about the front-only drive. A 2-wheel drive bike I would really, you know, but I want matching motors if I'm going to do that. Anyway, that's pretty much the end of that for now. Oh, by the way, just so that you understand that, and the other motor I was working on, I broke it. I realized once I started putting it back together and I got the housing on that one of the last things you should do is use a big hammer and a pin punch to try to seat it back down again, because as you can see from the hammering marks around the edge here, what I ended up doing was loosening up the magnets, which were supposed to be glued in place. And well, once they started to move, I tried to take it apart again, and rather than remove the housing, I wanted to remove the armature from the magnets and everything. Oops, there's the camera. I wanted to remove the armature, and well, you know, me being me, I grabbed the outside housing and pushed I should say, slammed the end of the axle down on the floor to try to pop it out, and as you can see, the end result is it broke. So I now have, well, I wouldn't say a wasted effort because I learned a lesson. That's one thing you don't do with a motor when you're trying to separate it. I will have to find a more effective way to do it. Probably a hydraulic press or something like that. I don't know. Anyway, just so that you learn, well, so I learn, everybody learns that, you know, you do make mistakes, you do break things, you know, until you learn what you're doing, that's the way she goes.